Hello, today we are talking about stairs. This is a steel stair, so it vibrates much more than a concrete stair would. So this staircase here has two very simple strings. It's a piece of sheet metal of maybe 5 to 6 millimeters thickness. The handrail is welded right to the string and the steps are screwed in laterally. Here you can see the steps. Last step is at the same level as the wooden flooring in the story above. This little stair is an escape device, which is not for normal use. You can see that there are two C-profiles here. This C-profile bears from this support to this support in the upper angle. And there's also the middle string, which is linked to the lateral supports here under the landing. And then this middle string is linked together by the vertical bars here, which go all the way through. And then the steps are connecting here one string to the other. You can see that this handrail is for security purposes only, while the one I'm touching here is for everyday use, so it has a stainless handrail. Here you can see a very nice emergency stair. You see that the central string is cantilevered out from the concrete wall. Then you have another smaller cantilever that supports the individual steps. You can also see that the handrail is dissociated from the balustrade being much higher than the handrail is. So here you can see a very simple stair with sheet metal steps, and the sheet metal steps are supported by this rectangular tube here. Two rectangular tubes, the upper side and from below. So here we have a stair which is supported at this point and here. But then, because the architects didn't trust the initial gesture, it is also suspended here with these rods from above. So that's quite unclear, and I think it's not a very consequent solution for the load-bearing structure of this stair. So here we have an example with steel stringers, and you can see that things get rather complicated at the landing. And normally the last step should be on the level of the landing in this case, but this would then lead to a much wider change of direction than we have in this case here. This is not a good idea here, so we would use cables rather than rods in this case. We have a staircase which is wide spanning from here to up there, so it needs a load-bearing structure which is rather high. You can see that it's around 40 centimeters. And I will take a look at one step. So the step here is 15 centimeters high and about 31 centimeters deep. So that doesn't correspond to the relationship that I've been discussing before. It's a little more comfortable. This is a very nice stair because it's cantilevering from the wall here, and it's rather wide. It's about 2 meters and 50. You can see that because of the cantilever, it becomes somewhat very soft as a staircase. And let's look at the relationship here. It's 29 by 17.5. It's supported by concrete beams here, while normally the step here is creating a profile which is high enough to support itself. So next to me we have two ladders. Ladders are very steep types of stair. And behind me we have a stair which is a little less geometrical, as to allow us to have a continuous underside. So the corner steps have been rounded a little as to allow for this effect.